All right, so here we have the table again, and it shows the counts for fawns and adult deer and the severity of the winter. The data is modeled by the equation F equals A plus B times capital A plus C times capital W. F is fawns, A is adults, W is winter. So we're supposed to use the first three rows to write a system of three linear equations and three variables whose values are A, B, and C. And so basically what we have is F equals, so we're just going to put equals here because that's what it really is. And it's going to be A times, and it's going to be a B, and W times, and it's a C. So that's really what we're going to get. And so from that, what we can do is we can write our three equations. So I'm going to say 606 equals. Now we just have A here, so we have A, all the problems. And so then I have plus B times A, so it's 700B, and then plus 5C. Then I have 246 equals A plus 300B. Better make it so I can read it later. Plus 3C. And then I have 686 equals A plus 800B plus 6C. So that's going to be my equation 1, my equation 2, and my equation 3. Now, what am I going to do? I think what I'm going to do is I'm going to basically get rid of the A values because then I'll have B's and C's left, and so that'll make things easier. So if I take 1 minus 2, what do I get? I get 606 equals A plus 700B plus 5C. Then I'm going to take a minus the 2, so it's going to be minus 246 equals a minus A minus 300B minus 3C. All right, so that's going to be a 2C. That's going to be a plus 400B. Those cancel. I'm not going to change colors this time. That's going to be a 0 and a 6 and a 3. Okay, so that I'm going to call A now. Then I'm also going to do, now, instead of doing that, let's do the bottom two. And because this one's bigger than this one, I'm going to say let's take 3 minus 2 just because that's kind of, well, actually, let's do 3 minus 1. I think that's what I'll do instead. You can do either way. I'm just kind of looking because this one, they're close to numbers. So let's do 3 minus 1. So now we've got 1 and 2 and 3 and 1. So that means we have 686 equals A plus 800B plus 6B, oh, C, not the B. C, and then I'm going to subtract off, so I'm going to take the opposite of A, or 1, minus 606 equals a minus A, minus 700B minus 5C. So on this side, I just have what, 80, and here those cancel. 800 minus 700 is 100B plus 1C, and I'm going to call this one B. Okay, so now I have A and B. So, I could do multiple things. I could get rid of b's if I multiply by a negative 4 on this one, or if I just multiply by negative 2, then I can get rid of c's. I think I'm going to multiply by negative 2 just because it's smaller numbers. I always wanted to work with the smallest numbers as possible. So, if I take, in this case, a minus 2 times b, I get what? Well, I'm going to have 360 equals, and then I'll have 400b plus 2c. And then I'm going to take a minus 2 times that, so it's going to be a minus what? 160 equals, and that's going to be a minus 200b. And then I'm going to have a minus 2c. Well, we got what we wanted. Those canceled. Now 360 minus 160 is going to be 200 equals what? 200b. Divide by 200. So b is equal to what? Well, that's just equal to 1. Okay. Well, now what I can do is I can solve for c because it's going to be easy to plug into this one. And so if I plug in b is equal to 1, I'll have, let's do it up here, 80 equals 100 times 1 plus c, subtract 100. So it looks like my c equals a negative 20. And now I can plug this into any of them. And because these have the smaller numbers, I think I'm going to work with number 2. So I'm going to say 246. So I've got that number. I've got that number. So 246 equals, now I'm looking for A plus 300 times B, and then plus 3 times negative 20. So that gives me what? 300 minus 60, so that's going to be 240. So if I subtract 240 and subtract 240, then I just get A equals, and I just get 6. Okay, so what I'm saying is here, I get the ordered triple A, which is 6, B, which is 1, C, which is a minus 20. So that's what I'm saying the solution is. And so now what we want to do is, it says we've solved the system, we wrote it in the equations A, B, and C, we found that. Now we're supposed to predict when there are 500 adults when this winter has a severity of 4. Okay. Um, I guess basically we probably should check this first because I think that's going to be an idea to make sure we have it right. So let's do the check and then we'll solve. So let's check one, and that one was the 606 equals. Now we said A was 6 plus 700 times B, which was 1, plus the 5, which is a negative 20. So that's a minus 100, and so that's going to be 606. So yeah, that works. Now we had the 246 equals 6 plus 300 times 1, and then plus 3 times a minus 20. So that's going to be 300 minus 60. And so that's going to be 240 plus 6 is 246. So yeah, that works. And here we had what? The 686 equals 6 plus, and that was 800 times 1 plus 6 times a minus 20. So it's a minus 120. So that's going to be what? Okay, now I better do this because I'm starting to think weird. And 0, 8, and that's going to be a 680 plus 6, so that's 686. So that works. Now we're going to do the problem part C. And that says we want to find F when the severity is equal to 4. There are 500 adults, and we're supposed to figure out the number of fawns. Okay. Well, we just plug it into the equation. 6 plus, and then we have 500 times our 1, because that was 500 of the adults, and then plus the 4 times the minus 20. So what's that equal to? Well, that's going to be minus 80. So it's 500 minus 80. That's going to be 420 plus 6. So that's going to give us 420. Oops, not 462, 426. 426 fawns. And so that's the answer to part C. Okay. So we've got the part C, we've got the check, and we wrote our first 3 equations. We solved for A, B, and C. That's kind of our solution in that set. And this one, we don't have any meaning for A, B, and C. They're just numbers to plug in. The A capital and W capital and F capital are really what matters in this case. And that's how we found the 426 fawns there at the end. All right, let's stop there and we'll come back for one last one.